Please introduce yourself and briefly summarize your education and professional background.
Yeah, I'm Pat McLarin. I'm Seequent Civil Segment Director. So my history kind of before I joined Seequent was I came from a geospatial background. So really in the planning and geographical information systems side, that's what I studied at school. But then I worked over the years working on technology development in product management type roles and project type roles for the geospatial industry. So mapping equipment I worked with Trimble for a long time, and then earth moving machinery and system controls for automated paving and earth moving technologies. That's kind of the point at which I came more to be associated with the civil workspace. And before starting at Seequent, where we really work with people that are focused on what's going on underground.
Let's talk a little bit more about Seequent and what you guys do, because it is, a geological kind of a software, not necessarily something that every civil engineer works with. Can you tell me a little bit about what you do, what the software does, and how the engineers use it to do their work?
I mentioned I'm the civil segment director, so that's just kind of language for the responsibility is really around everything we do to support people working in civil infrastructure and getting a better understanding of what's going on under the ground, so that they can make good decisions about how they're going to build, what they're going to build, where they're going to build it. That's informed by what's going on your site under the ground. So the remit of my responsibilities is really around our long-term strategy for everything that we do to support people operating in those projects, as well as the owners and the people that are managing those assets and infrastructures long-term for the benefit of the communities that rely on road, rail, water supply, and all of those things, right? So Seequent actually spans everything from the data collection right through to making designs that are for reinforced infrastructures, tunnels, dams, all of those kinds of things. We cover everything that you need to understand the ground, and of course we're part of Bentley Systems. So Bentley's all about the built world, understanding the infrastructure and the natural environment from a geospatial perspective. So you have all that context around where you're going to build that infrastructure and how you're going to build that infrastructure. So it's a very, very broad remit. It goes, perhaps in some circles we're known for geological modeling, in others it might be geotechnical engineering, but we actually encompass the entire geotechnical engineering process, I guess, from woe to go.
Okay, before we get into, I want to talk about some of these outlooks you put together, but just to get a complete understanding of how the role of underground engineering has changed and become much more important. It's no longer, an optional thing, like it's an important part. Can you maybe show some examples of how the underground modeling has become so important in today's engineering designs?
Modeling in general has become the key way that we develop and design and build infrastructure. So you really need to support that with the subsurface side. If you think about an infrastructure project being a multidisciplinary project, the geotechnical engineering is just like one of those disciplines that's going to work on that project. You might have environmental engineers if you're working in brownfields and you're trying to understand the impacts of perhaps hazardous materials that might be remnant in the subsurface where you're going to be excavating. So these are multidisciplinary projects, and so the modeling aspect comes from keeping pace with the modeling technology that we apply in every other part of infrastructure. So that the idea being that if we bring our understanding of the ground together with our understanding of what we intend to build, that we can see the risks and the interactions between those.
Now I want to talk about some outlooks. You prepared a 2026 outlook for civil infrastructure. Could you describe some of the key trends that you believe are going to happen and some of the major challenges that might impact this upcoming year?
I think we all grapple with uncertainty. So it's a bit, at some level, it's tried to say uncertainty continues. But hey, we're in January 2026, and like in the last week, the gold price went through $5,000 an ounce. So that's a tremendous independent indicator of the uncertainty in the world today, right? So it's real. And people kind of have to grapple with this in their projects as they execute their infrastructure projects. They've kind of got to deal with the secondary effects of this uncertainty. So that could be leading to increased costs through inflation on supply materials and things. It could be labor and skills shortages. If I'm looking at specific projects, you kind of have some projects that are winners, some projects that are losers. So, for example, just this morning I was seeing a major project in the US that is talking about stopping construction. That's the Hudson Tunnel project. But that's uncertainty at play. Against that, we've got at the macro level, we've got kind of high consistent demand. So everyone knows that there's an infrastructure gap, that we've got to build a lot more infrastructure to kind of close the gap, meet the needs of society, all the things that society wants from the infrastructure. And so data centers would be a good example of an area where there's like really sustained and strong demand for that. So it's not that demand for infrastructure is going to fall off a cliff, but not at all. It's actually the pressure is there to build infrastructure. So things like transportation projects, data centers, I think 2026 we'll see strong demand for those projects to be delivered. And then the whole data center phenomena, if you could call it that, I mean, that's what I think of it as. It drives energy needs, right? So now you've got the energy needs, and that's in terms of generation of energy, driving projects to deliver energy generation to support data centers amongst other developments. And then you need the grid to support it. So you've got changes driven into your grid, your electrical grid, that are needing to support that. So one of the themes that I touch on is this uncertainty, but yes, there is sustained demand. And then just stick on that data center topic for a minute. Speed to build is a really strong driver that we're going to see continue in 2026, right? The pressure to get executing, build things, you know how long I'm not sure where you're based, Todd, but most major metropolitan areas, you'll see these projects going on and they take a long time. And you get these traffic disruptions while the new system gets built, or a bridge, or whatever it is. So it feels like they take a long time. So everybody wants this infrastructure built yesterday. They want to be using it. So there's this huge imperative on speed to build. And you see that kind of come to the fore with data centers, where there's a lot of competition to develop and get these data centers up and running because of the increased demand that AI is generating. Also, we're going to see climate adaptation continue in 2026. That's going to drive some of the uncertainty that we have, extreme weather events. We continue to see these things occurring and unfolding around the planet. And so I don't think that's really a change. It's just more of becoming BAU, that we have these large weather events and our infrastructure needs to cope with those events. So perhaps our design factors need to change, or our ability to recover from said events, is kind of built into the outlook for those. So I think we'll see more climate adaptation coming into that. But I think the biggest thing, and it's no surprise to anyone that AI would be high on the list, right? This is probably the biggest disruptive thing that's happening in many, many industries, not just civil construction or the AEC space. We've got to adapt to new ways of working with AI. So there was this survey that was done. We can share the results with you on that report. This recent survey that was done around the impact of AI on the built environment. And, in that, 3/4 of people say that it's going to have an impact on their business. This is in the AC space, and half of them have adopted or are trialing how they're going to use that. And that's really focused on optimization of designing, improving engineering workflows, and improving your ability to do cost estimation and those things. So that kind of, it's here, people are using it. That's probably not a surprise to anyone, but it's very, very real, and it's kind of a disruptive technology. So we'll see more impacts of that. I think what the survey also highlights is that there's these risks around data sharing, and there isn't necessarily the project level controls around how that's going to be used. So that can either impact adoption or just mean you run this risk of moving problems around faster and more efficiently. So I think that really comes across in the survey response, and I would say that's a key thing to look out for in the new year or in this year. What's the response to all that? So one of the things, we can look at, okay, we've got these external forces, we've got this disruptive technology, what then is going to happen in the industry? So I think the natural response, people are going to invest in their people and upskilling their people to take advantage of AI and be able to better utilize that, understand it. They also need to kind of put the systems in place around data. So building resilience into your digital systems and looking after the data is going to be key. So there's a systems paper we refer to in the Outlook, and it's a couple of years old, but one of the key takeaways is data is the oil of the project engine.
All right, thanks, Pat. I appreciate that. So that was a lot you covered there. For what it's worth, I'm in Colorado. I'm in the western slopes of the state. So water is our big issue and topic out here.
Yeah. So there's some big reservoirs getting built. I guess that's not going to disrupt your day-to-day situation. I'm thinking of something like the I-75 or something that, that major works on one of those highways that was heading up into the Rockies there that took a long time, or is taking a long time. So you'd kind of bump into those projects while you're out and about.
I want to get back to the uncertainty. So obviously, I don't think anyone would argue how much uncertainty there is, but what can you actually do about it? Is that meaning like having lots of optional plans for different scenarios, or is it just being agile so that when something uncertain happens, you're able to adjust to it quickly? Like, what can you actually do to mitigate uncertainty?
Both of those things you described are actually relevant and sensible things to do. So scenario planning can be something that you could do. I think a more fundamental thing is just investing in your data management and your digital capability, because these technologies, they can help you respond, they can help you change, but you kind of need this basic oil in the engine, if you like, if you're going to respond to that. So if you think about, what these, I follow some reports that come out annually about claims in the industry and how many of them are kind of stemming from what source. This is claims on large infrastructure projects, claims and overruns. And the ground condition, the fact that you might get to site and things are different than what you predicted, that's kind of one driver of claims, but scope change is probably the other biggest driver of claims, right? So, and to respond to scope change whatever the source is. That's where if you say that that's the uncertainty about what's going to happen, so it could be funding decreases, so you've got to adapt the infrastructure that you're going to deliver accordingly, or climate changes, or you dig something up. Whatever the cause of the surprise, you need to be able to respond to it. So that's where I think that's the thing that you can do practically to mitigate the impacts of uncertainty in terms of an individual project, is look after the data on that project, manage that well, and your digital capabilities, so that you have the ability to respond to the new requirements or the new inputs and things that you experience on site.
Okay, so you mentioned investing in data management. Like, what does that actually look like? Does that mean finding software to deal with all of the mass amounts of data, or is it like workflows in terms of how you're using them? And what would you describe specifically as investing in data management to help alleviate some of these challenges that we're talking about?
Knowing where you're going to store your data. I think how you're going to access that. Is it going to be available to future projects? Who owns it? So, I think first and foremost, it's think before you invest in any sort of actual technology solution for that, you've got to be thinking about, what type of data it is, because different data requires different tools, I guess, to optimally manage it. But how are we going to access, how are we going to govern who's got control of the data? So some people will put that all into a big data lake, and they'll have people that can pull whatever you need out of it for you and serve it up to you. And then others might use a bespoke solution. So if we're talking about subsurface data that you go out and you drill a borehole on site, Seequent has products that, technology stack that will let you manage that data from logging it in the field all the way through QA, QCing that, and reviewing that, producing reports from that, and then connecting that into ongoing kind of modeling software for interpretation of that data. So that's a very different. You would never use anything like that for other types of data that be coming off your site. So I think you need to. When I say invest in data management, it's kind of thinking of, okay, what's the right horse for the course? What type of data am I going to manage? What are the right tools for that data? So it's going to vary depending on what kind of data it is that you're looking at. And when we think about some of those solutions, they've got a presentation layer that helps you understand and interpret that data, because having the data is one thing, and then kind of sharing it. How do I communicate with you about what I discovered on the site? I've got to present that data in some way. So I think the access to 3D visualization is kind of the key output. How's that data going to inform the decision making on the project? It needs to be accessible, but in a form that people can understand. So that's a very broad description of what it means to be thinking about data management, but I think there's going to be different tools that are suitable for different types of data on your projects.
Okay, just to put more of a kind of a picture on it, could you go through maybe an example of something that you use that you're very familiar with, just as an example or a case study of a way to get a better handle of that data?
There was a project out in the up in Canada, actually, where Hatch were basically getting up there in a very limited window on the season, and they were recording all the borehole information that they needed to work on design a railway corridor project. And so in that case, they were using digital data collection to accelerate the capture of the data in a structured fashion that then flowed back into the database, where people that weren't even on site could see the results of that. So they were kind of using that for two things: one, to accelerate the whole process of capturing and reporting on the data, but also this remoteness of the site was a real challenge for them with a limited window. So they were having the structured data and capturing it in that format. It kind of reduces errors. It means you're not waiting on people to get back and type things up at the end of their day. So it makes the individual engineers more efficient, and then the the onward use of that data, which ultimately is the purpose of collecting it, which is to come up with the design, then they can share that with the other people that were the designers on that project. So in that case, you need a data structure, which you're going to capture the data, and then you need things like the part of the platform like templates that'll let you report on that in a way that lets you communicate that with the people that are going to use that data for onward modeling.
And you gave some good advice there. Is there also, you've done a lot of this research, you've been looking at 2026 and also, data reports and what geoprofessionals are doing. In your coming across these things, if you were going to give out just a piece of advice or two to fellow engineering colleagues out there who might be, in your field of expertise, maybe you could quickly pass on some kind of advice that they should be thinking about in this year ahead to alleviate some of these problems for themselves, things that they should have on their to-do lists, or ways that they can stay on top of and do their jobs better coming into this year and in the future.
Probably when it comes to the subsurface side, right? Because that the uncertainty of what's under the ground could have a very significant impact on your project. So the overarching advice I would say don't skimp on your site investigation. Get more data, but that's not a carte blanche, just go log data anywhere. You've got to be selective about it. So you want to use the technology to help you optimize your site investigations. So what we see more and more is a number of companies that are using 3D visualization tools to get a better understanding of the prevailing conditions on their site using existing data before they even start their new drilling campaigns. And so they're saving time and cost on those site investigations when they go and execute them, but they're not sacrificing the quality on that. So that would be my advice is, the best thing you could do for your project is make sure you invest in your site investigation, but think about it before you go out. And then look after that data that you generate, because that's a huge asset to your business. The life cycle of infrastructure is very long term, and there's going to be more projects. So you think about all the changes that are going to happen to a piece of infrastructure over its life. You're going to be back there. You don't want to be drilling holes again where you drill holes in the past. You want to be able to access that information and use it as an asset as you have to adapt that piece of infrastructure to all of these changes that are coming over its life cycle. So that's my main advice. Invest in your site investigation.
All right, that's excellent. So as they're acquiring all of this data that they can find, some of it's, I guess it sounds like it's open source and available, and they can find. Yep. You don't want to just stack up your data, though. What are some ways that they might want to look at being able to not just having a lot of data, but being able to use it and make smart decisions from them?
Yeah, I think what we see is this friction between the project and the kind of the long-term view. So often we gather data in a project and keep it in a little project silo, and actually what you want is things that let you kind of give you the accessibility so that you can use that beyond a given project. Now, to do that and respect the conditions under which you collected that, you need to have good project level controls. Which data can I reuse versus which data am I not permitted to reuse? Some important things there. But I think that's the crux. How do you get it out of the project silo and into a centralized resource that you can access for, the next project or a wider applicability? The other thing about the subsurface is that there's the data that we measure, and then there's the interpretation that we make on that data, which is going to be the inputs to the design. Sometimes we might do a good job of managing the factual data information that we observe on site and keeping that in a place that we can get it. How are we linking that to the next phase of the modeling, the downstream interpretation, and what are the connections? Can we go and say, hey, this design decision was based on this data, this lab test information, and kind of have that connected together. So I think that historically we've We've done an okay job of managing our factual data. I would say that, there's plenty of people that will be wearing the cost of recollecting data that they should have looked after a little bit better in the first instance. But now I think the technology is there. You can manage that data as an asset, but then the next challenge, or the next frontier, if you like, is making sure you tie the underlying observed data to the downstream interpretation and design decisions that were made from it.
I know we could do this all day, but do you feel like there's anything like very related to what we're talking about that you want to add in before we stop recording?
I was just thinking about your question about, what, even as we go beyond 2026, what's the big challenge there? I think we'll see AI being proven to demonstrate, strong value in helping us design and build infrastructure. So I think it's one of the challenges for people working in the AEC industry is how's that going to change the way the industry functions. And, if you have business models built around billable hours, how's that going to potentially disrupt your world? So I think that it's an interesting, challenging environment for everybody, with great opportunities, but we're gonna have to change the way we work.